All right, I'll go ahead and get started with the introductory portion of this interactive Ask the Experts webinar. Today, our topic is risk management. And this is a topic that is related to one of our GCE online courses, which is the Fundamentals of Open Pit Slope Design. And this is a 1-hour webinar. We have a wonderful panel of experts on the topic of risk management, all of which have also been presenters who put together content and teachings on the topic of risk management for the course that I mentioned. So we're really lucky to have them here today. They will be answering your questions and discussing the topics, and we'll be welcoming you all that are attending live to submit questions throughout the webinar for the panel today, who I will introduce in just a moment. So the webinar today is put together by the Geotechnical Center of Excellence here at the University of Arizona in Tucson, Arizona. We are an industry-funded, member-led, interdisciplinary center. We perform collaborative and practical research and educational projects, and we bridge gaps between academia, industry, and fields of study as a goal for all of our projects. We are a small team who do many things, and we do these things with the help of industry and with the support of our members. If you are interested in learning more about the GC, we have our main email here, which is easy to remember, gce@arizona.edu. Please feel free to reach out to us for any additional information on GCE or its projects. And as I mentioned, we are member funded and supported, so we want to make sure to acknowledge those members here that you see on the screen. And without them, we would not be able to do the work that we do, so we're very appreciative. And if you are interested in learning more about becoming a member of the GCE, we'd be very happy to also talk to you about that. Just reach out, as I mentioned, gce@arizona.edu. Thank you to our members. And the course that I mentioned, for which our panelists are all presenters in, and the topic is one of the topics within a greater scheme of topics on the fundamentals of open pit slope design. So this is the course that I was mentioning here. It is currently running through its, finishing up its 2024 run, but we are starting a new run on September 16th of this year, 2025. And it is currently open for registration. You can go to our website to see a flyer for this course and to register for this course, which is mining.arizona.edu/GCE. Maybe one of my team members can throw that in the chat. Thank you, James. And I'd also like to acknowledge the Large Open Pit Project, who underwrote that course and also developed a wonderful guideline textbook on the topic of open pit slope design, which is used as a reference for that course and is currently undergoing updates for 2025. So I highly recommend that reference. All right, so now I'll introduce who's here today on the GCE webinar team. Myself, I'm Jillian Noonan. I'm a senior R&D engineer with the GCE, and with me for the team today, we'll be helping to field the questions and run the webinar. I have James McNabb, who is senior R&D engineer as well. James, thanks for helping out today.
Absolutely. Thanks for joining, everybody.
And Cheryl Bukowski, who is our professional development program lead. Hello, Cheryl.
Hello, welcome everyone.
And Benjamin Meyer, who's a software engineer with the GCE. Thanks, Benjamin, for your help.
Hi, everyone. Thank you so much for joining us today.
All right, and now it is my pleasure to introduce our panel today. So we have with us first Marco Arrieta. Marco is the head of the geotechnical department for the Line Creek operation with Elk Valley Resources. And Marco contributed a course module on the topic of geotechnical risk management and documentation. Marco, thank you so much for being here. We really appreciate your time.
Thank you, Jill, for having me. I'm really glad to be here. Thank you for the attendees.
Thanks, Marco. Next, we have John Whittle. John is a senior geological engineer with BGC Engineering, And John's course module contribution was on risk assessment methods. Thank you so much, John, for that contribution to the course, and thank you for donating your time and expertise today.
Yeah, thanks, Jillian.
And we have Eric Schwartz on our panel today, who is Principal Engineer with Pateau Associates. Eric gave us topics of risk mitigation, as well as external and internal review with regards to risk management. Eric, we're glad to have you on the panel today, and thank you so much for putting those modules together for the course.
Thank you, Julian. I'm glad to be here and look forward to talking to everybody.
Thank you. And we have Lucas Figueiredo, who is geotechnical engineer and owner of Atona Management and Innovation. And Lucas provided a case study on applied principles and tools for a soft iron ore open pit in Brazil. Thank you so much, Lucas, for being on the panel today and for your wonderful case study.
Thank you so much, Gillian. It's a pleasure to be here. I hope I can contribute with the doubts and the discussions. Thank you.
Also on our panel, we have Julian Venter, who is Geotechnical Director with Anglo Gold Ashanti. Julian also presented a case study for a saprolite pit in North Africa. Thank you so much, Julian. We're glad to have you with us today.
Gillian, thank you very much. It's a pleasure, as always, to be invited, and thanks again for the opportunity.
All right. So we're very excited about our panel today, and now I'm going to explain to you how you can submit questions for them. So as attendees of the webinar, you are muted and your video is off by default. If you would like to communicate with our panel today, you may use the chat for general discussions. But if you have a question for the panel, we ask that you please submit it into the Q&A, which is a button on your control panel in the Zoom webinar. You will be able to see the other questions that people are submitted. So if you see one that you particularly like, you can click it to give it a thumbs up, and higher rated questions we will prioritize in the queue. You can enter questions anonymously also by checking a box, so that is an option. And then just to let you know that we are recording this webinar and it will be posted to both the course site and to the GCE's YouTube page afterwards. And a quick note or disclaimer that any views or opinions expressed by the panelists today are their own, and that this content is intended for educational purposes only. And we thank you very much for joining us. So now, just to give you an idea, under the heading of open pit slope design risk management, here are some examples of the types of topics of questions that you might be asking our panel today. So geotechnical risk management documentation, risk assessment methods, risk mitigation, or external and internal review. And those align with topics in the course, which the presenters here today prepared content for and are knowledgeable on all of these topics. And this all, of course, relates to open pits and slope design. So with that, I will now welcome our live attendees to begin entering questions, and you can enter questions at any point through the webinar. We will go through some pre-submitted questions as well, and but you can start entering your questions as of now. All right, so we'll start off with a pre-submitted question. And for my panel, the way this will work is I will bring up a question, I will read through the question, so it will give you a chance to consider and think about your responses, and then I will open it up for discussion. So thank you so much for your time today, and we're really looking forward to hearing from you on these topics. So the first question that was submitted asks, is it true that risks are easier to manage or mitigate early into a project? That's the first part of the question. And then the second part is, what are the most important and effective measures that should be taken when risks are identified late in the project? So this question was not directed at a specific panelist, but I will perhaps welcome Julian. Would you mind being the one to start on this?
Sure. Thanks, Gillian.
Thank you so much.
Yep. So in general, it is true. But if you think about a typical project going from concept to pre-feasibility to feasibility and then implementation, the more time you have to solve a problem, the easier it becomes. So earlier on, you have more time than later on. But you also have more options to solve the problem earlier on than later on. But at the same time, in the beginning, you don't have a lot of data. So as you move towards a feasibility study, it probably gets a little bit easier to solve some of these problems because you lose a few options as decisions get locked in, but you also get more data. But once you get to the pit shell and you actually mine the crest, if you're about 2 benches down on a new pit shell, that decision locks in a lot of other decisions and it removes a lot of other options. So I'd say that it probably gets a bit easier up to starting a new pit, but then once you've started a pit, your options to change reduce very quickly. So that pit shell crest is your most important decision you could probably make because that drives everything later on.
All right, had to find that unmute button. Sorry. Thank you, Julian, and thank you for being brave to start off our Q&A session today. John, I saw you unmuted. Do you have more to add?
On the second bullet there, I was going to move on to that, and it's not a technical answer, but I was going to say the most important one is probably honesty, and then not sweeping any risks under the rugs just because they're supremely inconvenient that late in the project. People need to know, and so I don't know that I would make a particular tool or particular mitigation more important or effective than another, but getting it out there and into the minds of the people who need to know.
That's a good point, John. I'd probably add to that is get the facts right. If you're about to go into people's office and say that there's a big problem and it might cost money, make sure you get as many facts as possible and get it on the table and get it as early as you can.
Yeah, one point to complement on that and building into Julian and John comment is if you are in an execution phase, one, yeah, agree, you need to have the facts correctly because usually that is going to impact production. And then you need to have clarity on your response plan, meaning like if it's an active risk or an active hazard that is going to compromise in safety, you need to have a really good risk management strategy with actions that actually going to stop or prevent to place somebody at risk.
All right, thank you. And thank you to those that are starting to enter questions into the Q&A. All right, panel, we appreciate your responses to this question. Is there anything more you'd like to add before we move along to another question?
I think that covers it for me.
All right. So next I'm going to pull up another pre-submitted question as we get the live question into our PowerPoint. So this question is asking, how important is safety culture to implementing a risk management plan? And then further, another important question is how can someone as an individual or a team member working at a mine site best support the implementation of a risk management plan? And again, this is directed to the entire panel, so I will invite anyone who would like to volunteer to start to go right ahead.
I will take the first one. Safety is
Marco?
paramount. That is non-negotiable. So how important is it's high priority. Every single decision that you came up into a project, meaning feasibility, pre-feasibility, and even more important during execution, safety is what is going to drive your decisions and your implementations. And it's really simple. And complementing with the previous comment, in the previous question, if you identify your risk or your hazard up front, and you are not compromising at that point, resources because you're in a concept level or a feasibility level, you're in the design space. Now you're protecting the value of the company. But when you move to execution, then safety is your main driver, because every single poor performance that you will have in your pit or your configuration, now it's people executing that plan. So safety is paramount. And yeah, giving the floor to another panelist to share the opinion.
I'll jump in for number two. No, thanks for that, Marco. I'll take the second point. So I think the first thing to say there is to make sure that you know what your responsibilities are under that plan. And if we're talking about a TARP, a trigger action response plan, make sure that you know what your triggers are, where you have to respond, or you know where to get the information that people can find you, and know what you have to do. I'm thinking back to a particular TARP about 20 years ago where nobody actually read it beforehand, and when the triggers came, they didn't know what to do. So it was a rather interesting. So make sure that you know what you're supposed to do and be ready to do it and plan for that. And then the rest of it is, any brainstorming sessions, any planning sessions, put your information on the table and speak your mind. Obviously be respectful, but make sure if you have something to contribute, that you contribute. Don't just stay quiet and hope that the experts will solve it.
I think that you frame it beautifully, and that comes down to communication. The communication piece, you as an individual, is the best skill set that you can have. And it's not how to communicate, it's effectively communicate your information. Because remember, it's going to be somebody executing whatever that you are advising. And that needs to be clear, especially if you are in a high risk situation. So thank you, Julian.
Yeah, I'd like to add to those two comments from Julian and Marco too. I think safety culture is related to training and the emphasis of the training of the workforce on open pit slope design risks and problems in the pit related to hazards in the pit of rockfall, slope instability, those sorts of things. And so sites that generally have very strong training programs, including retraining or even toolbox talks about geohazards is generally one that would help implement a risk management plan and support the implementation of a risk management plan. Just wanted to add that. Thanks, guys.
Yeah, good points. So a follow-up question on that too is, Julian mentioned that as an individual, knowing what you need to do, what your role is, that all feeds into this communication. As an individual, where would that information come from to know what your actions are? Could you describe that for our group?
Look, if it's a geotechnical affair, sites are supposed to provide geotechnical awareness training. I think that's mandated in most jurisdictions now. So that'll be a starting point. If you're not the geotech, you'll find out, who the geotechs are. If you are the geotech, speak to your supervisor. They should be communicating all these risks to you. Most of the sites, they're actually all supposed to have a TARP. If you're in the geotech team and if you don't have a TARP or you don't know what the TARP is or where it is, speak to your supervisor. And if they haven't issued one, then, start pestering them to create a TARP, create a risk management plan, because they should have one. And if that doesn't work, then, go the next level up, go to the tech services superintendent, mining manager, whoever, is on that site. Ultimately, every site has a risk owner. In Australia, that's the quarry manager. In many other jurisdictions, it's the mining manager. Go ask them. Tell them I'm at the site. I don't know what I'm supposed. What the risks are. What are my accountabilities, and they'll very quickly help you out. But these things should be plastered over walls. They should be communicated. You shouldn't have to ask for it, but if you have to ask for it, you might volunteer to be the one to create it. So do it. Don't sit back.
And then continuously being aware of the nature of risk to change. So staying
Yes.
up to date with what is the latest on your risk conditions.
Absolutely.
The thing I was going to add, Jillian, which is kind of flipping this question on its head, is I think where risk assessments fall flat, and often they have a lot of good work embedded in them, and the team who did it are fully up to speed and have bought in, and then it's kind of imposed on people. Like, look, we did this great work, and this is our decision, and the why and all the kind of contributing factors aren't very well communicated, and the consequence of that is that individuals don't know their role in it. And yeah, getting the right team communicating like throughout the process, and not just like imposing the results of whatever big decision you're making, like roll it out, go to the stand-up meetings in the morning, like with the operators, make sure people have a chance to ask questions and be part of it.
Yeah, that's good, John. It's important to have that team effort. Any other comments on this question before I pull up one of the live submitted questions?
Gil,
Lucas,
can I
yes,
contribute? Yeah.
please.
Well, John and Julian and told us about communication. For me, this is the key word, right? I mean, a risk management program is not about tools, you know. Tools are means to achieve the final goal of the business safely. Risk management, it's more about how to communicate the hazards efficiently for decision makers, right? In the universal language of risk, in a simple and straightforward way. I'm telling that because along my career, I see a lot of people using risk management and the tools, failure mode assessments, and so on, as the final goal. No, they are means for the real final goal for the business. So communication is the key, and safety culture is essential for a straightforward and transparent communication of the hazards and the risks. That's my contribution.
That's very good, Lucas, and it's actually quite a perfect lead into the question that I was about to bring up. So if I could keep you on the line to follow up with, you mentioned that the tools are a means to provide for the communication, and that's what's important. But could you give some example of some risk tools that are commonly used and where in the life cycle of a mine they fit in? And that comes from Rob.
Yes, sure. Well, I just mentioned the failure mode effect analysis, FMEA. It's a very powerful tool. It's not new. Eventually, in the mining sector, is relatively new, but in other sectors, it's being used. It was developed in the aerospace industry, and have been evolved along the time. But again, if your failure mode analysis, effect analysis, it's just a spreadsheet without connection with the real controls and functional controls and communication. It's just a spreadsheet, you know. A very powerful way to use the failure mode, the FMEA, is to combine with the event tree analysis, which gives you a more holistic and chain risk events overview and fault tree analysis, and afterwards the more governance tools like bow ties and risk registers, because something that I've faced along my career as well is the geotechs in the operations are shouting about the risk, the hazards, and so on. But when you see the corporation or the corporate risk register, it's not aligned with what the geotechs are talking about in the field. So it must be very aligned, because in the end of the day, the risk management tools is a way for you to compare risks, right? A slope, instability with a fire or other sort of hazard and risk for the decision makers to take the right decision timely. So yeah, this is how we should use the tools in a proper and straightforward manner.
Thanks, Lucas. I might see if John has anything to add. I saw you unmuted just as I said that because
Yeah.
I know your presentation was on risk assessment methods specifically.
Yeah, and I liked everything Lucas has had to say, and just a couple things to add are, I think, like most things we do, there's a good argument for starting simple and adding complexity as it's needed. Sometimes the quick version will narrow down the things you should be thinking about. So I think a lot of the tools have a place at different stages in the life cycle, and they're kind of work. They're complementary to each other. But then the other bit on the life cycle I wanted to mention is it depends what data, like, do you have the data to actually do that methodology or not at the stage you're in? And if you don't, then your result isn't going to mean too much. So like Lucas said, there early in a project, often you have the more qualitative tools. And as you collect data, you can start putting numbers to things and maybe getting more specific.
Gotcha. Thanks, John. Anyone else in the panel? I would welcome you to unmute.
Yeah, Julian, just to add to what John had to say, I think early in a project, like at a pre-feasibility or feasibility level, anything you can do to get your data to a higher confidence level will help you come up with a better design. I think that's an important concept that needs to be discussed when discussing risk, is how confident are you in your data. I can't count the number of times I've seen projects with really conceptual level geology or hydrogeology stuck onto a feasibility level study, and it's expected that the geotechs on site will bring up the designs to operating level later. So I think that's a tool that should be stuck to very strongly, that geotechnical involvement for projects at a through the life cycle from conceptual to pre-feas to feasibility, really push for high confidence in geological models, geotechnical models, and hydrogeological models. I think that's a great example of early in the life cycle. And then later, obviously, it's more things about practical monitoring technologies that match, the failure mechanisms that are supposed to be experienced by the slope design. So making sure that monitoring matches those, and if you can get it, and most people do nowadays, is real-time monitoring is important for that. Having backup monitoring systems in place is also very important. Integrating monitoring with other tools, whether weather-related or water-related data that can help figure out what anomalies are, is important. And then having controls that manage those specific geotechnical conditions are all important during operations. So those are kind of two of the end members of the life cycle. When it's all planning and stuff, it's easy to do sit in the office and plan a slope design, but if your data's not good, it's not that great. And then later on, you really need to monitor to make sure the design is performing the way it's supposed to, and you can react to things that are not expected. So that's the short version.
That was a really very good summary.
Okay.
Yeah.
I'm just reading off of my notes from my presentation.
Really good. Yeah.
I'd like to add to that. It's a very good answer. Thanks, Eric. The one thing, I said earlier that picking that pit crest is probably the most important decision you can make. But if you're dealing with a greenfields project, you probably only have drilling and geophysics and for your geological model. And that means that geotechnically you don't have persistence values, and you haven't actually seen exposed structures in the field yet. And so once you start a new pit, that first few benches is your best time to try and actually see what the rock looks like, especially if you get into fresh rock for the first time. So that's when you probably focus more on data collection and design validation, making sure that your assumptions were right before you go down too far and you lock in your final toe. And that's an opportunity often missed. A lot of projects, we don't need geotechs until right at the end, and we buy some radars and everything's fine. But no, that mapping in the first stage, structural model updates, that's real risk management tools right there.
Yeah, I agree, Julie. Great point.
So this discussion is kind of aligning with one of the live questions that we got. So I'm going to pull that up and see if it triggers any additional discussion. It's an interesting question from Hannah, who says, even with advances in geotechnology, much of our approach still relies on monitoring until movement occurs. So just like Eric was saying, then you want to monitor to confirm that what you expect to happen is maybe happening or not. But do you see opportunities to shift toward more proactive geohazard management by involving contractors earlier in design and using continuous ground support during operations to reduce risk, improve safety, and support production goals? So I know Eric and John both mentioned that data and knowledge can be a limiting factor early on in the design that might grow later on in the design. So what are your thoughts, additional thoughts on Hannah's question? Eric, maybe would you like to start?
Sure. As far as trying to be proactive, having quality data is one of the things that we've already gone through. I think monitoring is getting to such a stage where you can be very precise in picking up movements before deformation that matters occurs. Meaning, lots of times INSAR will pick up things, or subsurface monitoring from inclinometers or TDRs or what have you might pick up things before you see deformation at the surface. And so if you have as much monitoring as you can proactively, you may pick that up before movement actually occurs and matters and causes you to change your mine plan or stop a phase or evacuate people, that sort of thing. By involving contractors earlier, I'm all for trying to get the knowledge base as bulletproof, if you will, as possible, so that there's no question what kind of material you'll be encountering as you mine a slope. So, the whole idea is to prevent surprises, and mine it till it fails just doesn't cut it too much. So, having all those questions, answered before you start excavating the slope are really important. So, and I think your comment on ground support during operations, unfortunately, that's very expensive. As anybody that's tried to do that can attest to, I don't really see that as a broad-based option, if you will, but it can be used in key areas, especially around ramps or infrastructure that you put in the pit, water wells, pumping stations, that sort of thing. I've seen it a few times there to reduce risk, but continuous ground support everywhere in a pit is probably not going to happen. I hope that answers Hannah's question.
Yeah, thanks, Eric. Any other panelists like to jump in? Julian?
Yep. So no, Eric, very, very good answer. I totally agree with you. Ground support in general is not an option in a pit simply because it needs to be too big, so it becomes expensive, and also it disrupts operations. But what you can think of, we spoke about data quite a lot, but if you can detect a potential failure before it's actually a failure, before it starts moving, you have a lot of time to solve it. If you have to wait until it moves, then time is limited. So anything you can do to get data, to validate your design beforehand will make things better. But that also includes things like experimental slopes. So the case study that I presented in my talk, that wasn't the first bit at that mine. We actually had many experimental slopes, and that was actually another one of them, where early on we try and mine a few benches as deep as we can and see if it fails. It works really well in saprolites. That's the best way to get a field scale test and try and validate some of your numbers, and potentially that might change your bigger slope later. So any experimentation, an open pit is actually a big laboratory. You don't have to wait till the bottom to learn things. You can try and do temporary things early on that might help. Undercutting faults that you know about early on a bench scale, back analyze them, mining vertical benches in saprolites. As long as you can do those things safely, experiment and try and learn about your pit.
Thanks, Julian. Marco, I see you had your hand up.
Yeah, just to complement, and I agree with Eric and Julian. I believe, and in my professional experience, you need to split your approach basically in two main ways. One is your proactive approach, and one is your reactive approach. If you allow that instrumentation guide your decision, that means that you are reacting to a problem. Because if the wall is painted by red by the instrumentation, that means that something happened, or is happening, or it will happen. So you are reacting to the instrumentation. That is a reactive approach in my operational experience. But in the proactive way, you can tie that to the previous question. If you in advance collect data, identify your main structure, because everything just settled down into the structural geology. Geotechnical engineering and slope stability is just a geometrical problem. You have certain geometries with certain orientations that is going to create an issue for you in the future. If you can identify that, if you can assess the uncertainty around the data, and how reliable is your design, then you can strategically design your instrumentation to be placed in some ways that is going to confirm or validate your assumptions. And then, in the top of that, if that risk is going to be real and present for people and for value for the company, you need to have a backup plan, and that is your response. If your instrumentation is showing you that the trend is towards a poor performance, then you need to trigger your response plan. That can be just a redesign, a design change, but need to be incorporated in your life of mine, because you don't want in that operational execution phase to raise the hand and go to the upper management with a suggestion that you need to step out, and that is going to cost $100 million loss in revenue. So priorly collect your data, identify your hazard during your design phase, plan for it, design your instrumentation, and then react accordingly with your data. So
That's great, Marco. Thank you. There is another question that I think Marco sort of just answered, but first I'll ask if there are any other comments for this before moving on for Hannah.
Gillian, just a
Yeah.
compliment. As Julian said, I think the best opportunity you have is as soon as your rock mass is exposed. This is the reality. So as quickly as possible, you must fit back your model. And currently, we have advanced tools on implicit modeling and data acquisition through drones and other sort of tools that allows you to review your model almost online if you want, in order for you to adequate your design and timely. So this is one, talking about geotechnology, this is a very a proactive way for you to deal with these uncertainties and adequate your design before the displacements start to occur. Just a compliment.
And also, I believe answering the question that I was just about to bring up, which I'll bring up just so we know what I'm talking about. But this came in again also from our live group asking, how can real-time monitoring tools be combined with predictive models to help spot and deal with slope stability issues before they become serious problems in an open pit mine? So I heard Marco and Lucas and others just discussing how the models are predictive tools. You can use your monitoring data to then validate your predictions and then react, as Marco was saying. Is there anything else that others on the panel or Marco and Lucas would like to add with regards to this specific question from Anonymous?
Yeah,
John?
one thing to add is an example of something I was working through last year where didn't have a choice. Like there was a big moving slope, and no matter what option we had to choose from, we would continue working below that big moving slope. And that's where the risk assessment process really shined, because we were able to use the real-time monitoring tools to formulate the risk assessment. The chain of events would be completely different for a brittle failure than a ductile one, and we're able to use those tools to characterize that. And then with the response that we saw in the monitoring to digging various places, we were able to forecast forward, when we would be in certain TARP levels, so how much cost there would be for various options and how much downtime. So the real-time monitoring was an excellent predictive tool in more than just a slope stability way, but as for downtime and cost.
That's great, John. Thank you. Any others?
Something else to consider on
Go ahead, Eric.
combining models with monitoring tools is the value of validating your predictive model. I'm sure we've all been involved in slopes that we think it's going to happen here, but it ends up happening somewhere else as far as instabilities. So having early on, as John mentioned, having the ability to have confidence in your model so that you know with a fairly good degree if a buttress will work or a step out will work and how much that would cost is really important, and it's worth having that validation early on. So I just wanted to have that.
Thanks, Eric. And just if you were starting to lose your audio just a little bit for the last part of that. I think if you sit, a little closer, we might hear you better.
Sorry, you want me to repeat that?
I think I was able to hear it.
Okay.
Does everyone agree? Yeah, okay. It was just starting to get a little quiet. All right, Marco, I see you have your hand raised.
Just a minor comment. We hear a lot across the industry the term modeling, and we need to be really careful with that because there's nothing wrong with the model. The model is as good as the user input and the data that you input into the model. But remember, real-time monitoring is a real ground behavior. So that is real. That is happening. So I really like how Eric framed it, that the real-time monitoring help to calibrate your model, to validate your assumption, and to make a better predictive tool. But we cannot lose from our side that the monitoring piece is the actual real ground behavior. It should be driving your forecast performance of the wall based on your model assumptions.
All right, I see agreement from Eric. All right, well, thank you for the good question. We have just a little over 10 minutes left in this webinar. So I'm going to move on to another kind of comment, but I thought we could briefly touch upon this statement, and the panel could comment on their thoughts. So this person was saying that a critical piece in a risk assessment is the composition of the risk assessment team. So does the panel agree with this statement? Do you have any thoughts further about this statement? John, I see you unmuted. Go right ahead.
Yeah, it's absolutely right. Like, people have different training and different stakes in the decision, and they need to be there to participate. It's kind of the first big decision before you start anything is who needs to be in the room.
Yeah, it's a good point. I can probably add, in my view, it needs to be all the stakeholders, right? So the people that's going to implement the plan, the technical people that has the technical knowledge to understand the plan, people that needs to finance the plan, those are the kind of people that need to be there. But I have seen a trend in some companies to fill the room with people that have absolutely no idea about mining, HR and so on, just because someone said you must have a diverse group of people. And then the process gets dragged out, and people that's never been on a mine, that's never done anything technical, get involved in these things. I think that's not a recipe for success. Get a diverse group of people, but make sure you've got people from operations, drilling and blasting, geotech, mine planning, mine management. Those are the kind of people that need to be in these rooms. If someone actually has something to add, then for sure. But don't just fill the room with a renter crowd. That doesn't work.
That's a good comment, Julian. I think the only thing I would add is some of the more successful risk assessments I've done in larger groups have a single person that keeps track of what gets into the risk assessment. That person has a lot of experience and is kind of the arbitrator, if you will, to kind of quell the competing interests and make sure that everybody's interest is heard. I've also found that smaller groups, the bare minimum, usually can come to a conclusion quicker. Large groups tend to go into chaos really quickly. So just keep that in mind. But getting an experienced arbitrator could be important, depending on the complexity of the assessment.
That's a very good point, Eric. I used to run the risk assessments at mines, to try and steepen slopes. And you often find that some of the older, more experienced people are very loud, and nobody wants to have an opinion, because they might be judged by this person. And I got around it by putting things to the vote, to anonymous votes on little voting slips, and so nobody knows who voted what. And that was sort of an attempt to let everybody have a voice. It worked really well. It was just time consuming, but a good moderator will solve that too. Make the louder people a bit more silent, and make the silent people a bit more louder.
Thank you for those comments, and thank you for that statement to our anonymous submitter. So we have, let's see, we have four questions in the Q&A that are still outstanding. Each one has one vote, so let's see, we'll bring up another. Unless I'll call for any other final comments on this while we move on. All right, thank you. Okay, oh, we've got a couple more votes. We've got two, okay. We've got 3 for 1 here, so that is the one I will choose. Okay, this one comes from Erica, and Erica's asking, what are the main geotechnical risks that should be identified and quantified before the opening of a new pit? I know, Julian, you mentioned that earlier. And how can the application of a probabilistic approach improve decision-making in slope design? So thank you, Erica, for the question. Does anyone feel inclined they would like to start with this? I think we may cover this one fairly quickly. Marco, I see you have your hand raised.
Yeah. So I would like to touch on the probabilistic approach. So I will split that in 2 main avenues. One is uncertainty, and the other one is probability. So if you are asking about uncertainty around your decision making, that is just how much, I will put it in a simple way, how much scattered is in your data. So you don't know. You don't know your main values. You will have a lot of uncertainty around your modeling or your decision making point. If you are talking about probability, that is how compact is your data, and each variation, how it's going to affect your mine plan or your execution. So that depends on the data, how much uncertainty you have in your input, and that uncertainty, how it's going to drive your output. And then, assuming that there is a new pit, and you are just opening the first bench. If you're opening the first bench, it's just for your operational spaces, rockfalls, for example, because you don't have any larger structure affecting your pit. If you are talking about how your shell is going to interact with your geology and with your structural model, that now we are talking more about interramp, multi-bench failure mechanism. So your risk assessment need to be split in 2. If you're opening the pit, it's make sure that your people is safe in your daily basis. So that is rockfall. For a strategic point of view, make sure that you identify the interaction between your shell and your structure, and you identify in the planning space which hazard is going to become important, and through time, when they are going to be present, and how much time do you have to address it. So, Lucas, I see that you have a comment.
Yes, perfect, Marco. Yeah, totally agree with you. Just a small compliment is talking about uncertainties. We have to split what is the model uncertainties regarding as well, not only geological and geotechnical modeling, but hydrogeological modeling uncertainties, and structural, which is often the major issue in uncertainties in geological uncertainties, as well as the variation, the coefficient of variation of your material over there naturally can be more for or not, as well as the economic consequence, and then combine with the probability, because otherwise the probabilistic approach itself can lead you to wrong decisions, right? Model uncertainties, in what extent is tolerable or not that uncertainty, what is the level of the consequence. There is a very good piece of work of Renato Maciotta for the large open pit exactly on this, which is very useful if you guys want to go deeper in this issue.
I'll just add a little bit to that. So a lot of people get hung up on the actual probability of failure, and I'm a big proponent of that. So I think it's the way to go. But where I find most value is remember, you've got to make sure that your probability includes all the important factors. That means it's not just cohesion and friction angle. It's structural orientation, the presence of potential rogue structures. Everything that could potentially affect your slope needs to be included in that calculation. and then analyzing that all the scenarios, understanding what's important. Is your slope driven by a structure? Is it driven by soft rock? We're dealing with a slope at the moment that's actually driven by rockfall because it's just so strong that's the only thing that matters. If you know that, then you know what to manage and you know what to do to go steeper if you want to. But that all starts with an honest appreciation of your probability and what goes into it, not the final number, but the actual calculation.
I see some nodding heads in agreement from the rest of the panel. Julian? Eric or John, any additional comments on this question? No? All right, I think Marco, Lucas, and Julian all handled that quite well. Thank you very much. And thank you, Erica, for the question. All right, I'm going to try to squeeze one more in. What do you guys think? Let's see. From Kevin. So I thought this was an interesting question. And with just a few minutes left, maybe just a high-level discussion on this. But basically, Kevin is saying that in many mining operations, designs are repeated year after year under the argument that it has always worked. And they are overlooking the potential of modern tools like 3D geotechnical models, advanced structural simulations, and data-driven planning. So what role should or could leadership play in shifting this mindset from tradition to a risk-informed, technology-enabled approach to design? So any thoughts or recommendations for Kevin in our remaining couple of minutes? John, go ahead.
Yeah, I run into this often, and I think meet them where they're at is the short version of, like, often it's people responsible for the mine plan and the money who are pushing back on changes I'm recommending, and the something that's worked, it's not the only thing, but something that's worked is to communicate in terms of money, like communicate a risk cost and demonstrate that, okay, you could do this, but in 2 years you're going to need a big step out, and that's X cost, or that's an early pushback, or so kind of framing your work in the terms that they're working in is a useful way to help shift this mindset.
Thanks, John. Marco?
Thank you, Kevin, for the question. And yeah, just to compliment John, one, you need to talk in their language, and their language is money. The consequence of this lack of decision making based on risk is just money. And our role should be trying to be proactive, meaning, Kevin, like if you are in the reactive mode that you're executing, and then your instrumentation is telling what is going to happen in 2-3 days, that mindset is not going to shift. But if you commence to work in the proactive approach, that you have 2, 3, 4, 5, even 10, 20 years in advance, a risk assessment for your bit geometry, then you can communicate that. Look, man, this large structure is present. The uncertainty associated with that is X. The consequence of not drilling, planning properly, it's Y. Usually in the mining industry, hundreds of millions of dollars. And if you don't take care about this problem in 3, 4, 5, 6, 10 years, it's going to be present and it's going to compromise your mining sequence. So shifting from reactive to proactive, and I really love it how John Freeman is talking in their language, communicating in the consequences space that means money.
Yeah.
Maybe just to add to that, so the agency problem, management that manages money or mines for other people is quite a big thing in mining, because mines are owned by shareholders quite a lot of the time, and a GM is only interested in their own tenure, which might be 2 or 3 or 4 years in many cases. They're not going to do anything now that will make their replacement look better. So what I found with hard-headed management is to try and frame the things I want them to do in such a way that they get a little bit of a gift this year, right? So package the solution with a bit of a win this year so that they look good, but behind the scenes you don't even have to tell them there's a big win for their replacement. And that sometimes works because whoever I deal with gets to win out of the transaction. The next person also wins, but they never know about me. But the current person gets something out of it. That convinces them.
Some strategy there. Any final comments? We are really out of time, even though I would love to continue the conversation. It's a great question. All right. I'm sure we could keep talking for another hour or two or three. Risk management is such an interesting and broad topic. We've touched on so many parts of that today, and our panel did a great job in discussing based on their knowledge and experiences. We really appreciate you joining us today, and thank you to all the participants who also joined us and submitted those great questions. For those who did not get your questions answered, we apologize we can't get to them all, but if you are a student in the Fundamentals of Open Pit Slope Design course, please go there and put it in the discussion board, and we will make sure to connect you with our panel here today. We probably will have other webinars that touch on similar topics, so bring it to another webinar, and hopefully we'll be able to get it addressed for you. But thank you so much for your participation, and thank you very much to our panel. I'm going to go ahead and close out the webinar, but I will leave on the screen the information for the course in which all these panelists are presenters, and you can learn more about this topic in a deeper fashion if you wish. So thank you so much to John, Julian, Eric, Marco, and Lucas. Really appreciate you all, and thanks for a great panel discussion.
Thank you, Julie.
Thanks, Julian.
Yeah,
Thank you.
Thank you all.
Thank you,
Bye
everybody.
now. Bye, guys.